paper is the study of UX practitioners' roles in designing real-world enterprise machine learning systems. This research focuses on how interdisciplinary teams that include UX practitioners design real-world enterprise machine learning systems. We conducted a survey with product managers, interviews with interdisciplinary teams, and individually with UX practitioners. The findings show that non-technical UX practitioners are highly capable with designing AI/ML systems and collaborating with technical team members. Our findings suggest that existing HCI design techniques are insufficient. We propose adaptations to design practices and conclude that some existing research should be reconsidered. Key design issues have been frequently raised by the HCI community, but also from those concerned with ethics and the wider societal impact of AI. However, there remains relatively little in the way of research exploring how systems are designed in practice. This paper builds on the limited work focusing on enterprise or B2B machine learning systems and conversational chatbots. Emphasis was placed on the interdisciplinary nature of the teams working on these types of projects. Research was outside of the big technology companies such as Microsoft, Google, and IBM. Related work. We looked at designing with complex systems. So this paper engages with a relatively small though growing area that investigates actual design of AI/ML systems. So systems where the outcome is non-deterministic. This type of research continues to provoke inquiry within the HCI sphere. New human-machine partnerships. Existing design methods will appear ill-equipped to account for the dynamic qualities of AI/ML systems. Farouk and Grudin, for example, aim to capture the hybrid or symbiotic relationship between user and system with their notion of human-computer integration. A number of approaches have been proposed as the design of AI/ML systems is being led by a perceived need for new knowledge. New and extended design practices. Other research confronting the complexities of AI/ML systems has placed less emphasis on new knowledge and more on changes in practices and processes. Examples are Yang et al. And Valan Allen's approach. What's it like on the ground? Our work follows in the footsteps of existing research by engaging with designers directly. Our work is separate from the AI design guidelines, which have been created by big tech companies to focus on designing interactions and explainability. Other research has focused solely on speaking to data scientists and natural language practitioners. Methods. 3 methods were used to answer the research questions. Method 1 was an online survey with product managers, 27 recruited to take part. Method 2 was semi-structured interviews with 2 interdisciplinary teams. And method 3 was individual semi-structured interviews with 7 UX practitioners. Findings and discussion. The first of 3 main themes in this section was adapting design methodologies for AI/ML systems. We found that designing for post-launch was a very important adaptation. Further HCI research on design practices for post-launch and maintenance of AI/ML systems would add further value. A second one was whether experience prototype or building the POC should come first. Prototyping can yield unrealistic functional requirements for the system. We also found that splitting the work into the two streams was potentially a viable process. Different approaches to teamwork has not received much attention in HCI, especially for more complex problems and data types. Another theme was that the methodology needs to incorporate ethics, which currently design methodologies don't do. Participants saw this as an important way of designing, a important part of designing AI/ML systems. There was a healthy skepticism of whether transparency and explainability was an issue that could be resolved through the interface. Participatory design was an approach that was used by participants and could provide a way in determining where people can play active roles and in tighter synergies between humans and machines. The second group of themes was collaboration on the design of AI/ML systems. We found that there was no dichotomy between the rationalistic and HCI approach. This was driven by the fact that teams did not really feel like they knew how to design for AI and ML. This was in contrast to previous studies where we found that UX was seen to be an afterthought. We didn't find this to be the case. A possible reason for this difference in findings could be that this study sought out UX practitioners that were involved in the design of AI/ML systems and screened them accordingly. We also found that UX practitioners have the skills to collaborate on AI/ML projects and were able to adapt to the designing of AI and ML systems. We also found that UX practitioners were using their skills to understand their team members and collaborate with teams on the design of the AI/ML system. The third group of themes is around the shift that is needed to design AI/ML systems. So we found that there's no simple solutions for when you're designing for complexity. One of the main areas of complexity was that the organizational structures for the B2B projects can be complex. And what we were finding was that UX practitioners try to reduce some of this complexity through more in-depth user research into specific niches, rather than trying to go broad and create a more general solution. We also found that prototyping has a number of purposes and needed to be high fidelity. The primary goals for prototyping was feedback on the user's mental model, whether a design would be accepted, and if a design was feasible. We found that high fidelity prototypes with real data was needed for this. It was not the case that participants found prototyping difficult, as previous studies have found. For chatbots, UX prototyping was not important, and we found that prototyping can be complemented with other evaluation techniques such as design critiques. Another theme was that the user interface is one of many components. We found that current design methodologies are too focused on the user interface, and they're not suited to designing how things work behind the scenes. UX practitioners focused on practices as a result, rather than being fixated on design process. The HCI academic community should consider how they might engage in more research into the system design as a whole. Additionally, there was a skepticism, and we found practical flaws with some HCI design practices. So humans in the loop was seen as something where there was a lot of skepticism in terms of whether it was feasible for niche B2B products and whether the quality of the data generated would be good enough. There were similar concerns with Wizard of Oz prototyping, which was seen as unrealistic. We found that instead of only conducted empirical studies for when developing new HCI practices, these also need to be grounded in the real world. Concluding remark. In conclusion, HCI design methodologies need to be updated. We found that UX practitioners have found new ways to impact wider AI/ML system development. Previous studies have been too focused on interface design, and the HCI community has much to learn from the study of real-world in vivo system development. There are opportunities for HCI in rethinking where UX design should play a role in AI/ML system design, and future research should look to broaden its scope and look at the influence UX design has on development life cycles, teamwork, and wider organizational structures. Thank you.